let me begin with section A. Then the rest, kayo na yung mag-solve dun sa iba. Then you choose. So for section A, we are given the properties. The section A is, can you still view what I am writing?
Yes po.
Okay, so the properties of the section for section A is 13,800 square millimeter for the area. The moment of inertia I sub x is 293.63 times 10 to the 6. You have I sub x 293.63 times 10 to the 6th millimeter to the 4th. And then you have I sub y, which is equals to 67.59 times 10 to the 6th millimeter to the 4th. So we are going to determine first the value for C. T sub C, that is a coefficient in the critical section. This is a given formula. Again, ang gagawin nyo lang is magmemorya ng mga formula. Ito ang medyo complicated sa steel design. Ano? So you have the different formula and all you have to do is to substitute. So you have the square root of 2 times pi squared. Then the modulus of elasticity, which is of course, kung hindi given sa problem, lagi ang steel natin, modulus of elasticity is 200,000 megapascal. And according to the problem, the value of Fy is 250 megapascal. So the value for C sub C here is 125.66. And according to the problem, the column is unbraced. The unbraced length of the column is 3 meters. So therefore, K is equals to 1.0. This is unbraced. So we are going to use the value for K, which is equals to 1. So we are going to try. Let's try the section A. Ang ginawa ko lang, inumpisahan ko dun sa section A, sa B, C, at D. Pero kung kayo ay para lang mai-illustrate ko sa inyo kung anong gagawin, ano. Pero kung kayo ay magde-decide sa ganito, tapos ang pinahahanap ay yung lightest section, mag-umpisa kayo dun sa pinaka-light. So kung ang yung lightest section natin, ibig sabihin yung may pinakamaliit na area. So ang may pinakamaliit na area dito is itong section, alin? Okay, section B, 11,550 square millimeter. So, pwede kayo mag-start dun sa section B. Okay. Kaya lang dito sa aking computation na pinakita ko sa inyo, yung section A. Okay, just to show you kung ano ang dapat nyong gawin. Okay, and then later on, mag-decide kayo kung aling section ang gagamitin ninyo. Okay, so we have for section A. KL over R is equals to 1.0. The unsupported length is 3 meters, so that is 3,000 mm. Then the radius of gyration can be determined using the formula for the radius of gyration. This is another formula that you have to take note of. Square root of I, that is over A. The square root of moment of inertia over the cross-sectional area, that is the radius of gyration. So kung hindi given yung radius of gyration, all you have to do is to make use of this formula. So we have 67.59 times 10 to the 6th millimeter to the 4th for the value for the area. Yung pinakamaliit, yung mas maliit na moment of inertia ang gagamitin nyo kasi ang hinahanap natin, yung mas maliit na radius of gyration. Then, area is 13,800. So, this is the minimum radius of gyration. Based on calculation, we have 69.98 mm. So, the radius of gyration is 69.98 mm. And then that means the slenderness ratio is 42.87. And if you are going to take a look, since KL over R is less than the C sub C coefficient, 125.66, then we are going to use the value for Fs, the factor of safety. Factor of safety is equals to, since you have this condition, the factor of safety that we are going to use is 5 over 3 plus 3 over 8 multiplied by KL over R. This is KL over R all over C sub C minus you have the value of 40 KL over R cube all over 8 C sub C cube. So our factor of safety is equals to 5 over 3 plus 3 times KL over R is 42.87 all over 8 times C sub C is 125.66 minus KL over R cube 125.66 cube all over 8 times C sub C, which is 125.66 cube. So we will have the factor of safety is equals to 1.79. And we shall use this in the determination for the formula for FA. FA is equals to 1 minus KL over R squared divided by 2 times C sub C squared times Fy all over factor of safety. Okay. So if you are going to determine the value for the critical stress, you have 1 minus KL over R is 42.87 squared divided by 2 times 125.66 squared multiplied by Fy of 250 over 1.79. Then Fa is equals to, by calculation, 131.54 megapascal. We are going to use this in the determination for the critical load. Therefore, our critical load will be equals to Fa times area, which is equals to 131.54 Newton per millimeter squared multiplied by area, which is 13,800 square millimeter. So this would cancel out, this one will cancel out. We will have the value for load which is 1,815 kilonewton. The unit is 1,815 kilonewton. And since this is greater than the given load of 1,800, the given load is 1,800 kilonewton. So that means this is safe, 1,815 kilonewton for the critical load. It is safe section. Okay, so the rest would follow for if you are going to compute for the other critical load, and then